A very warm welcome again. In our today's virtual meetup, we will start off with an introduction to the basics of machine learning and how it is being applied to a variety of industry use cases. We will then provide an overview of H2O3, the #1 open source machine learning platform. We will also walk you through a demo of H2O3 and highlight its features and capabilities. My name is Saurabh Kumar, and I'm on the marketing team here at H2o.ai. I'd love to start off by introducing our speaker for the day, Parul Pandey. Parul is a Kaggle Grandmaster and a data science evangelist here at H2o.ai. She combines data science, evangelism, and community in her work. She has been promoting women in STEM, and to that effect, recently launched a community called Women in Coding and Data Science. She is also an active writer and has contributed towards various national and international publications. Without further delay, I'd now like to pass it over to Parul.
Thank you, Saurabh, and a very warm welcome to all of you. And thanks a lot for being here today. So as Saurabh mentioned, we're going to start this presentation with a fairly basic idea of what machine learning is and how do you get started with machine learning. And for today's session, I am going to focus more on our open source platform because it is open source, it's available, anybody can use it and contribute to it. But I'll also give you a small introduction about what we do as H2O Ai. So without further ado, let's start the presentation. So what can you expect in this session? I'll talk a little bit about H2o.ai and our learning center, which came into being a few months ago, and there we are imparting courses on AI fundamental and machine learning fundamentals absolutely free. So I'll talk more about on how you can leverage it and use it in case you're trying to switch into data science. I'll then further go into explaining about what H2O3 is, why it is useful, and maybe why is it better than the other machine learning libraries that you might be using. I'll also show you how you can install it and so that you can start using it right away. And then we'll go over some real life case studies using real data sets, and we'll see how we can achieve that through our open source platform. So firstly, I'd like to give you a little background about H2o.ai. So H2o.ai is the name of the company as well as name of one of the products. And we were founded in 2012, and we have our headquarters in Mountain View, California. Last year, we got a Series D funding, and we've been trying to democratize AI and help as many companies and people leverage and use AI for various things and various problems, and even we're helping NGOs and people who want to use AI for good. Apart from that, we also have an academic program and academic license for people in colleges, in academia, who would want to use our products for their research. So we give them a license for a year, which is absolutely free. You only need to apply for that license. And I'll just show you in a little while how you can do that. So we have a lot of products. We have our open source machine learning at scale. We have our automatic machine learning enterprise platform called Driverless AI. And we also have an AI platform for business users called H2o. So we have customers in almost all verticals of the industry, be it insurance, be it finance, banking, healthcare, and as you can see from the list, AT&T, Franklin Templeton, Lego, Pepsi, Roche, Kaiser. So we have customers in almost all industries, and this really gives us a wider view of how machine learning is being used industry-wide and what sort of problems companies are coming up and how they are leveraging and using our technology for that. We have our headquarters in Mountain View, but we are global. We believe that talent can be anywhere in the world. We do have offices in New York, London, Paris, Ottawa, Prague, Chennai, and Singapore, but a large part of our team also works remotely. So this is a slide which I think we're very proud of, because this shows you the power that we bring to our platform from the minds of the people who are champions and experts in their fields. So we have 18 grandmasters in our company, and they are located all over the world, and they help to test our projects. They help to use their expertise and their recipes, their winning recipes in Kaggle, and those are then incorporated into a product. Now, for the ones who do not know, Kaggle is a fairly famous data science platform from Google. So it was acquired by Google, and it has about 5 million registered people who are competing on various data science competitions, or there are companies who post their competitions on Kaggle, and then people, they try to come up with the best and best optimized solutions. So all these people, we get to work with them, we get to see how they approach a problem and how would they solve a problem, and then using their expertise and then expertise of our own data scientists and software engineers, everything comes together as a product which is known as Driverless AI and H2O3 and H2Q and so on. So if I were to tell you what H2O.ai means, so this whole slide will actually encompasses the whole fact that all of our products are tightly knit in together, and they make this whole wonderful, you could say, H2I ecosystem. So whereas on the left-hand side, we have our open source project called H2O, about which I'm going to talk today. It's an in-memory distributed machine learning algorithms platform, completely open sourced. We also have H2O open source engine, which is integrated with Spark, known as Sparkling Water. Both of them are open sourced. You are all welcome to contribute, use, and sort of practice and use it for your own machine learning problems. The one in the center is H2O Driverless AI. So this is our enterprise platform, and we have licenses for this. And we have capabilities like automatic feature engineering, interpretability, auto visualization. So it's an end-to-end platform for data science. Then we have model ops. So that's called H2O model ops. That's used for deployment platform, and it's built for DevOps and MLOps, and helps to monitor the models in production end to end. And then we also have a new and innovative platform called H2O. So there you can make your own AI apps and you can submit them to the marketplace. And this helps to actually have AI answer your questions. And you can have all sort of apps like data labeling app. You can have, for instance, what you can see here is demand sensing apps. So all these apps are then placed on the marketplace, and you can use them just like you have your Google Play Store and all, but these are AI apps. These are some of the logos that we have, and we currently are proud to say that almost half the Fortune 500 companies use our open source product, and you can see these are from all over the world. So this was about H2O.ai. Now I also want to tell you how at H2O we're trying to help others to learn data science and machine learning, and then either use it to change your careers or to start working on some machine learning problem. So we came up with a learning center a few months back, and the learning center basically was created keeping in mind these few things. So if you're absolutely new to AI and you want to get started, we have our AI Foundation course. So it is a code-free course, and it basically delves into the idea of creating a project from the business point of view, how you think about how do you put a business problem as a machine learning problem, what are the attributes that you want to know, what are the basics of machine learning. So once you get familiarized with the basics of machine learning, and if you're already familiar with that, you can then take on our ML Foundations course. So ML Foundation course, or the Machine Learning Foundation course, is a hands-on course which is currently active. So it's going on, the third module. And we are showing you how do you code and how to create end-to-end machine learning projects. If you're a student, then you can apply for our AI academic program, and that will give you a license for a year, and you can get more hands-on practice. You can also ask your doubts from the community, from the H2I community, as well as from the H2O makers. And we'd love to support you in any project that you want to do. So you'll get access to our driverless platform absolutely at no cost. If you are an experienced data scientist, you've worked in the industry, you've worked on a variety of problems, but now you want to understand about what is automated machine learning and data science at scale. So we have our self-paced tutorials there. And if you are looking for an instructor-led course, so we have our own training team and we have instructors there. So they could help you in understanding more about driverless AI, H2O and sparkling water. So quickly, I'll just show you how does our learning center look like. So that's a learning center. And like this is telling you, this is the module that we're currently working on. If I go to home, so this is a learning center and you have a lot of courses here. So you have the AI and ML foundation courses for beginners. We have self-paced tutorials. These are the instructor-led courses. There are specific tutorials related to H2O3, MLOps, sparkling water, and there are other learning resources. So you can just go to training.h2o.ai and you can just find the one that suits you the best. Now let's begin with today's hands-on tutorial, and let's see how we can use H2O's library to perform machine learning. So I'll take an example of supervised machine learning because I think it's one of the basic forms of machine learning and everybody sort of has an idea about what it is. So very quickly, I'll just go over the two basic types of supervised learning called regression and classification. So in regression, your aim is to actually find a number. So the target variable should be a continuous value, for instance, a number like how much will a customer spend. So that's a number, $85. What is going to be the interest on a loan? 7%. What is going to be the height of a person? So say 7 feet. So for this, you plot your existing data points, and then you create a regression line, which would pass through most of the data points. And for any new sample that you have for which you want to predict, you're going to then try to plot and see how far is it from your existing line. So there are a few algorithms which we use for this, like linear models, random forest, gradient boosting, stacked ensembles, and so on. As for classification, in classification, we try to create a decision boundary between the different classes. So if it's a binary classification problem, say there are just two classes, yes and no, or yellow and gray. So we're going to try and create a decision boundary and try to separate both the classes as far as possible, which doesn't happen in real life. You'll still have some mistakes. Some yellow will come in the other boundary and so will the gray, but that's the whole idea behind classification. So since we are sort of creating a boundary, so here the target value or the variable that we are trying to predict is always in kind of categories like yes or no, true or false, spam or not spam. And the algorithms that I used for this is, again, a lot of algorithms can be used for both classification and regression. You just have to change the quantity that you're trying to predict. For example, naive Bayes. Naive Bayes is one of the standard algorithm that had been used earlier a lot for finding out whether an email is spam or ham, not spam. And like I said, these are some of the standard problems, classification and regression. So finding whether a tweet is positive or negative, or also known as sentiment analysis, whether a person going to default on a credit card loan or whether it's a yes or no. On the other hand, regression problems are when you predict the sales for a company or the profit for a company or the loan for a company. So now we have some idea about what a classification regression problem is. So let's start and work on it. So for today's session, we are going to use H2O3. So H2O3 is our open source architecture. You can ingest data into H2O3 from a variety of sources, say HDFS, S3 buckets, or even your local system or SQL. And once it's ingested into the compute engine of H2O, you can perform a variety of operations. You can explore the data, you can perform exploratory data analysis, you could do feature engineering, you could select the features which you think are more important than the others, you could leave out the features which are not important, you could create new features out of the existing features. Then you start your training, and once you train it, you'll evaluate your model on your validation set, and then finally see the predictions on the test set. And once that whole modeling part is done, you can also store it as a Mojo model object optimized. So that's a Java object, which could be then used for productionizing your problem, and you can use it on any other platform. So you could score it on Spark, Kafka, Flink, and wherever you want it to. A very important point here is that this whole H2O compute engine is written in Java. And so this also makes it really, really fast. But then having said that, does it mean that we would need to know Java to use H2O3? No, because we have APIs in the most common languages that people use for data science, like Python, R, JSON. We also have a web interface wherein you don't need to code. You can simply click and run, and it has all the features there. You can train a complete model, and you can also export your model. So H2 machine learning platform is a distributed platform. So we have multi-node and multi-core implementation. So you have the algorithms, like for instance, XGBoost. So H2O has its H2O version of XGBoost. And why would you use H2's version? Because we have the implementation of it is that H2 enables XGBoost to use multi-nodes and multi-cores. And the core algorithms have been written in Java, but the APIs, like I said, are available in the other common languages. You can also easily deploy these models to production because they are written in Java. So that makes it very easy. And it works on Hadoop, Spark, EC2, Kubernetes, your laptop. So what kind of algorithms are present in H2O? So we have all the common algorithms, both supervised and unsupervised. We have their implementations in H2O. So algorithms like GBM, random forest, deep neural networks. And we also have our AutoML version, automated machine learning in H2O itself. So that doesn't require you to actually select any model. It does all the machine learning and all the training itself by going through many iterations and checking which models gives the best solution. Additionally, it has some other inbuilt capabilities. So for instance, missing value imputation can be handled by H2O3's algorithms. It can also normalize and scale your values, which are very essential because sometimes the values are, so there's some values which are like pretty large and there's some values which are pretty low. So you need to scale them between 0 and 1 so that, and that works best for any machine learning algorithm. Also, this takes care of the categorical variables. It auto one-hot encodes them, so you also don't have to worry about that. We also have the option of automatic early stopping. So if you're training your model and if it feels that the metric is not improving anymore, you can stop the training the process and save on your time and computation. You also have automated machine learning, like I said. Other things like grid search, random search, cross-validation are also available. And finally, you can view the variable importance, like which variable is contributing maximum to the prediction. You can also see the plots automatically. You don't have to actually create them here. And so if you were to look at a very high level architecture of it, this is how it looks like. You have your familiar IDs and languages. You might be using a Jupyter Notebook or PyCharm, RStudio, and from there, you would use all these available algorithms in H2O, and then you have distributed in-memory computation, which is scalable to terabytes. So let's see how we can install H2O3 now. So the installation is pretty simple. You could go to the documentation page and it shows you how you can install it for different platforms. So you could run from the command line. You could install it in R. You could install it in Python via pip, but you have to make sure that you have all these dependencies installed. And you can also install it on Anaconda Cloud. You can also install in Hadoop. So there are a variety of ways in which you can do. You can go to the documentation and you can just type in downloading and installing H2O and you'll get. So locally, it's very simple to install. So I am using Python. I'm using Python, and for Python, I'll just install these dependencies and then I will install H2O. All right, so now when we've installed H2O, let's start with our classification case study. So the problem that we're going to do today is a fairly known business problem, and it comes from banking industry about whether or not a mortgage loan will be delinquent, that is whether a person will default on the loan or not. Now, this problem is a fairly common problem, and a lot of industries actually use machine learning for this, including banks and financial institutions. The data set that we are using for this is the Freddie Mac data set. So Freddie Mac is you could say a government agency in US, which last year actually made available its the entire data for 20 years for the people to ensure transparency. And it gives mortgages, so loans on the mortgages, and it made that data available to people so that they could use it. And we took that data and then we tried and let's see what we can infer from the data set and how many people actually return back the loan and how many people do not. So the workflow that we're going to follow is we are going to ingest our data set. We'll do some data analysis and feature engineering. And then we're going to create a model and we're going to choose from the available models. And then we'll try and understand about the metrics. So let's start with the demo. So here I have my Jupyter notebook, and I have actually pre-run the experiment just to make sure that it doesn't get stuck during the live demo. So I already told you about H2O and the installation part. So now we need to test the installation. So to check that everything is in place, I'm going to import H2O3 and I will initialize a cluster. So whenever you start H2O, you need to initialize a cluster by writing .init. So this creates a connection between the Java virtual environment and your Python client, because like I told you, H2O is written in Java. And it creates a cluster. So a cluster is actually a group of nodes and they will work together. Depending upon how many nodes you have, this will be shown here in this information that gets populated on your screen. I am using my laptop. This has only one node, but if you've got more than that, this will shown here. This also shows me the time zone from where I'm working and how much memory is being taken by this H2O here. So by default, H2O will use all the cores and about 25% of the system's memory. If you can see, total cores are 16. But you can also allocate it a fixed chunk of memory if you want to by specifying here. So then you can specify the maximum memory that you want to give. Now, our objective is to predict whether or not a loan holder will default. So I have created two models here. So one I've used a linear model like logistic regression, and another is a boosting algorithm called gradient boosting estimator, just to compare which one works better. So I'm going to import the data set, and in H2O we imported by writing h2o.import file, and I am giving it the location of the data set. But if you have it in your system, in your local system, you can also import it from there. So once it has been imported, we are going to look at the first few rows. So the dot head function shows you the top 10 rows, but you could even write the how many you want. If you write 5, you will see the top 5. So I can see some familiar variables like credit score, payment date, etc., which normally are those attributes which we see in such loan data. We are actually interested in this last column that's called delinquent, which is telling us whether a person has returned a loan or not. So false means no, the person does not default, and true would mean yes, the person defaults. So now we have two categories, true and false. Additionally, by writing .describe, we can see some statistics of our data set, like what is the mean, maximum, how many zeros are there, how many missing values are there, and so on. If you look closely at the data type, you'll see some of the familiar ones like int, which stands for integer data type. You will also see some real, which stands for real data type, real numbers, and there is enum. So in H2O, categorical data type is enum. So all the columns which have categories are denoted by enum. So there are total of more than 5 lakh samples or people in our population, and there are 27 attributes for them. Let's quickly look at the distribution of the variable that we're trying to predict. And this shows that there are about more than 4 lakh people who do not default. So they return their loan, and just 18,000 approximately who do not. So this is a very heavily imbalanced data set because you just have 3.6% of the samples which are true. This is fairly common in real life data sets. You do find highly imbalanced data sets. And this is just a testimony to the fact. Now, once we have a data set and like it's a real problem, we just have one source of data set. And unlike a lot of machine learning problems where we are given separate test and training sets, we are normally not given that. So we have to split the data set ourselves. So we are going to split it into two parts. One is going to be a validation set and one is going to be a test set. So I am dividing this loan level dots. I'll use the function dot split frame, and I'll say this is 0.7, 0.5, 0.15, and I'm giving a seed, a random seed, just to maintain the reproducibility and so that I can get the same answers again and again. So 70% of my data set is going to be used for training my model. Rest 15% would be used for validating. And the last 15% will be used for training. Now, why do I have two different data sets? Now, this training testing set, is a set that I'm just going to keep it away. I will not use it for training or validating. So my model is never going to see this test set. This will only be used at the end when I will finally compare my two models. On the other hand, I will use the validation dataset to validate my metrics. So I'll train my model, and then I will see how is it performing on my validation set. And if I feel it's not performing well, I might retrain it again with different attributes and so on. So validation data set can be used again, but the test set will be just kept out. So now I'm going to assign my target and predictor variables. So we have 3 sets of data. We keep the test away. We just have validation and training set. Now to train a model, we'll need 2 kind of variables. One that we want to predict, and the others with the help of which I'm going to predict. So in H2O, you can't directly give the lists, the names of the variables, but you have to create X and Y list or variables, which you then feed into your function. So Y is delinquent, and X would be all the other variables except delinquent. And there are other variables also which I've ignored. And why did I do that? So the product type, I ignored it because it's just constant value. The value isn't changing. So if I'll show you again for the product type, you'll see it's the same value. Okay, so this is product type, and this is just a constant value. So this is not going to help the model in any way because it's just constant. There are other 2 variables that I have actually ignored: prepaid and prepayment penalty mortgage flag. Now, just imagine if you are going to a bank and you want a loan. At the time when you apply for a loan, a lot of attributes, you make it available to the bank: your name, your credit score, or maybe any other loans that you've taken, etc. But this variable prepaid is not known to the bank at that time. The bank doesn't know whether you will return the loan or not. So this variable is not known at that time, and so is this variable. So this is also not available at the time when a person is applying for a loan. Now, if you give this information while training, you are going to introduce these features, and this is going to reduce leakage in your machine learning model, because prepaid and prepayment penalty mortgage flag are highly correlated to whether or not you will default. So if your prepaid comes yes, that means yes, the person will not default. And if your prepaid is no, this means yes, the person is going to default. So this information you cannot just pass to your model, because this is exactly what you're trying to predict. So these are highly correlated, and you should always make sure while exploring your data that you should remove such variables from your data set. Otherwise, you would see a great result on your training set, but your model is going to falter very badly on any unseen data. So by using the other variables, we are going to start our model, training a model. So I'm using a H2o Generalized Linear Estimator. So the Generalized Linear Estimator, also known as GLM, is actually a family of models. And there are a lot of, this is actually a suite which has a lot of models, like from Gaussian to binomial to like ordinal and gamma. There's so many. You could just read if you're interested. You'll also understand when we use, how do we interpret them. Today, we're going to use binomial regression because we have 2 variables. We have a category, and binomial regression is also used for classification. And if you go further down, you'll see how this handles categorical variables, how it handles numeric variables. So you'll have a close idea, because if you know about categorical variables, you would want to know that why I did not encode my target variable, which was false or true. I should have encoded it as 1 and 0. I don't need to, because my algorithm will take care of that. So I give the family binomial. This makes it a logistic regression model now. I give it an ID, it's just some sort of a name, so that in the future, if I want to refer to this model, I'll refer it with its ID. Now we'll train the model by writing .train. I give the X and the Y variables. I give the training frame as train and the validation frame as valid. And now if you see, this gives you a warning. It says dropping bad and constant columns. So we did ignore a bunch of columns, but this also tells me that the loan sequence number is also a constant column and it should also be dropped. And so it drops it. Now, once I create my model, it's time to see how it is performing. And if I just pass at GLM, it will show me a summary of what has actually gone under the hood. So this gives me a lot of details, which I can quickly go through. So it gives me some of the metrics which are reported on the train data. So this is MSC, RMSC, log loss is this much, and AUC is this much. So I'm going to go with AUC right now because also it's highly imbalanced, unbalanced data. And so my AUC for training data is 0.85. It also creates a confusion matrix on its own, telling me how many false positives and true negatives and false negatives do we have. So how many correct predictions we have, how many wrong predictions we have, how many were actually true, but the model predicted them to be wrong, and vice versa. I will also have metrics for my validation data. And here the AUC, or the area under the curve, is 0.844 or say 0.85. And if you go to training, it was 0.85. So you can see they're so similar, and this shows that our model has done such a good job in generalization because both for training and validation, the AUC is pretty close to each other. Also, we can create a plot, and the plot will give us an idea as to after how many iterations have the performance of the score isn't improving. So using this, what we can do is we could use early stopping. So here we say that after 4 iterations, there isn't much improvement in our score. So we can use for early stopping as a metric, and we can put it for while training a model next time. I'm not doing it, but I'm just telling you that this is also possible. This is very interesting because this also gives me the variable importance. So if I'm going to write variant underscore plot, this gives me which variables are most important and which have actually contributed a lot, which have contributed to the predictions. And interestingly, I see that the top 4 variables are service name and then the bank. So first one is Wells Fargo and JP Morgan and so on. So the banks are immaterial, but what is important is that, service name variable is very important because for all the banks, this variable has been shown at the top. And the property state is also important. The credit score comes here. So we then kind of get an idea as to what a model must have chosen, to create the model and to train the model. This is also important for explainability because you then don't just say, okay, the AUC of my model is 90, but what you say 0.9, but you will say, okay, these were the variables which my model thought were important. And then a person with domain experience can verify them and say, yes, it's absolutely correct. It makes sense. So we have different banks of services, and in a linear model, each one makes a difference. Now, let's make the prediction on the validation set that we had chosen. And we make the predictions and we look at the top 10 predictions. So again, we know our data set is imbalanced. So out of the 10 predictions, 9 still come as false. So they say, no, these people will not default. But for one, we get true. So we get to know that, yes, this is going to default. But how this is predicting is, if you can see, this gives you some probabilities. So we don't get one number that yes or no, what we get are probabilities. So for instance, for this person, it says that there is 99% chance that this person will not default, but there's about a 0.5% chance that this person will default. Now you have to decide where you want to keep your threshold. Again, let's say for this true. So this has 65% chance that this will not default, but it has about 34% chance that this will default. So now you have to decide what is your threshold. So if your threshold And I'll show you where the threshold is. The threshold comes here. So you can see maximum F1 and threshold is 0.122396. So what does this mean? This means that anytime if the probability is greater than 0.1224, it is predicted as true. And if it is less, then it is predicted as false. So for the sixth prediction, you see that the probability is greater than 0.1224, yes, but for the others, the probability isn't greater than 0.1224. So that threshold is 0.1224. Any prediction greater than 0.1224 will be given as true by this model. And you can decide where you want to keep your threshold depending upon, do you want to catch more people who do not return the loans, or your idea is to not get false positives, So that comes out from your domain experience. Depending upon what you want more, do you want your model to be more specific or you want your model to be more sensitive? So once you know this, you can print the default AUC, and which comes out to be 0.84495. So now what we can do is we can test for another model. So the process would be the same. I'm going to just quickly go over GBM, and it's the same process. And in the end, we'll just see and compare the result on the test set. So the test set never sees the training, the modeling part at all. And we are just going to test, and we get that for the linear model, our AUC is 0.85, and for gradient boosting machine is 0.86. GBM is giving you a better value here, but again, it isn't that much greater performance. That's also because it's a small data set probably that we're using. So, but it's just that how you can compare. And once you complete this, you need to shut down your cluster. You have to shut down the virtual Java environment that you had created. So this is the whole process, the way in which you sort of train a model, from ingesting the data to splitting the data, and then how you analyze your results. I did not go over one more aspect of it, which is called grid search, which is also available, and that is also a function that's available. So quickly, I'll just tell you what it does is it is used to tune your hyperparameters. So these hyperparameters are those parameters of a model which have to be set even before you start training, unlike the parameters. So the parameters of a model are something that they learn when they're trained. But hyperparameters are like, for instance, if you say decision tree, giving the number of leaves or the depth. So all these things are something that you have to actually give before even you start modeling. Most of the times we go with the default ones that have already been set in the algorithm, but we can also tune them and use them. And so there are methods available for that. So how do you search which? So tuning isn't that easy. If you think manually, you can try, it'll be like millions of parameters that you will try. So for that, we use a lot of methods. Today, we have a lot of auto tuners also, Optuna, HyperOp. But for H2O, we have two ways in which we can do the grid search. So the Cartesian way of grid search and the random search. So you can just go and read about them in the documentation. It's simply you, again, define your model, and then you give these hyperparameters. So these are the hyperparameters that I need to set. How will I handle the missing values, whether I'll skip them or whether I'll mean imputate them. And this will be my search criteria, and it will go and it'll give me the best parameters. So for instance, here it has given me that the best way it thinks would be to skip the missing values, and then it gives the best AUC for that. So it has already done all the calculation, number of iterations, and it is finally given me, telling me that, and that it has sorted it in the descending order, giving you the best AUC first and the worst in the end. And then you can feed in these values. So it's you can just go over and you can further refine your answers by tuning your model. What I want to actually show you is how can you recreate this whole experiment without coding. So if you don't want to code, but you want to use H2O's capabilities, there's also another way, and that is through the web interface. And what I'm going to do for that is I'm going to convert this into a regression problem. So instead of predicting whether a person is going to default or not, I will now predict the interest rate. So since I'm going to predict a number now, the same problem gets converted to a regression problem. How will you access your web interface? So when you start your cluster, you get this address and your H2 instance is running at that address. So if you just simply click on it, what you get is your flow environment, which is this. So when you click, you'll get this environment. I've opened it on cloud actually, but you'll open it in your local system. And this is same, it's just that you need to just select things. So on the left-hand side, you get a lot of ways which clearly tells you if you want to import files or want to import a SQL table or etc. But you can also do the same thing by going here. So the first thing would be to import your data set. So you click on this and you click on import file and you import the data set. So I have already imported. It's the same data set that I have used for my classification problem. I'll click on this and I'll import my data set. And once this is being imported, so this has not been imported right now. I'll have to parse these files for them to come to our memory. There's a very interesting thing here. So I told you about the distributed and the multi-core and multi-node capability of H2O3, and that I can show you here. So this is a water meter. So this shows you the number of CPUs. Okay, each bar represents a CPU, and blue color shows you the idle time. So my CPUs are idle. Now, if I start parsing these files, you see there's an activity which has started, and now you can see, I think my data has already got parsed. Okay. And now you see how all my CPUs are getting used. And hence this makes the ingestion part, data ingestion and training so fast, and it's already done, so it's closed. So you see 100% done. So now I can look at my data. It's the same thing, okay, what you were seeing there. I can see all my columns, I can see the type, and I can see how many are missing, how many zeros, min and max. The 5 lakh rows, the 27 columns, this is the compressed size. I could split my data set. So I can split in 75 and 25 ratio. Say I will only split into train and test or validation. I'll put my seed. You can also add a new split. I'll create it again. So now I have 2 frames, training and validation. Next, I can create a model. And when you click on model, you see so many examples. You can choose any model that you want. Let's say this time I'm using XGBoost. So this is H2O's implementation of XGBoost. And as soon as I click my model and select my model, I get all these parameters. And now it becomes so easy because what each model does is the description is given here. So you need to give a model ID. It could either take it as by default, or you can just use one that you want. You can choose a training frame, which is going to be trained. I will choose a validation frame, which is going to be valid. Endfolds, if you want to do cross-validation, you can select this. I don't want to do that right now. I will select my response column, which is original interest rate. And you can also read while you're going down. Names of the columns to ignore. Any column that you want that should not be included. You could just say, for instance, you can click on next and check the ones that you don't want. For instance, I don't want product type. I don't want postal code. You can also show only the columns which have greater than some particular missing values. I'll set my seed here, and you can see maximum depth, minimum rows. So all the attributes of a model are shown here, and you can just go on and select. And also, you also get an explanation and the best values. So like learning rate should be given from 0 to 1, row sample rates per tree should be given from 0 to 1, and so on. I'm going to leave all the other as it is, and I am going to build my model. And here my model is started. So it's also giving you how many trees it's creating. XGBoost, it's actually sequential way of creating trees. And yes, now it's done. It gives you the time also, and I can view my model. So this is the scoring history. So if I click on this, this gives me the training and validation scores. And again, it shows me that my performance has been improving after how many iterations. I also get my model parameters that I had selected. Like before, I get variable importances. So when we are trying to predict interest rate, the first payment date becomes the most important variable, and I can also see. So these importances are scaled, okay? So one will be the most important, and the last, or the variable at the lowest end, will be the one less important with respect to one. And you can also see a lot of things, the columns that were used, and number of trees were 50. This is the scoring history. So this exactly shows you how much time it took for each iteration. And if you want your variable importance to be in a tabular form, you can get that too, because sometimes you want to show this to other people or other departments, and then you might not want to show it with a graph. So you can just take these and copy. You can also, if I just go back to the models, you can, so this is, I selected XGBoost. You could also select AutoML, and then AutoML would have given you the best model also, so which it thought was the best model for this particular task. So you could give, and you again have to use the same thing. This is my valid, and I don't want a blending frame, and choose, I want a leaderboard on the, and that's it. And so it will take time because it will use a lot of models, and it will iterate on a lot of models, but this will actually give a good idea as to which are the models which you think would work well on your current data set. So this is going to take a lot of time, so I'm just going to cancel the job. And once you are done with everything, you need to shut down your cluster. Also, you can export your model, and if you want to use it or save it, you can just download the data, download your model, and then it just gets downloaded in a zip file on your system. So that is how you use the web interface in case you don't want to actually write code or anything. Some of the resources that you would find useful. We have a glossary also, where you have a list of all the, you could say, definitions for a lot of jargon that I use. So this is the AI glossary, and you could click on the ones that you want to know about. So this is glossary terms. So like, what is unsupervised learning? What is automatic machine learning? What is H2O flow classification? So you get definition to a lot of them here. What is Mojo that I was talking about, and what it is. So you can go to the glossary and understand more about it. We have a lot of public data sets available in H2O's repository. You can use them to practice. You can install H2O, more about H2O architecture, and we have some other blogs and resources which you can go over. I think that's all for the session. I hope you've got some understanding about how H2O3 works and how you can use it to perform machine learning and use it for your own projects. It's faster alternative to other libraries because, like I showed you, it's based on the distributed architecture and multi-core and multi-node capabilities. So I'll be open for questions now, and that's all from my side. Thank you.
Great. Thank you so much, Parul, for a wonderful walkthrough. I guess a bunch of questions are asking about resources as far as the training goes, the academic program goes, the documentation site goes. So could you just very quickly flash your screen
Okay.
so that people can know how to find these things? Maybe go to the website and show it real time.
Yeah. So so you just need to type in. I'll just zoom it out. So you need to just type in training.h2o.ai, and when you type that, you get this page, which is known as the Learning Center. And then this Learning Center has you can create your account here so that all your work is then saved here. And then you can from the site select on home, and then you get a bunch of ways in which you could learn. So like I showed you the AI and ML Foundation course, which is currently live. We are going to have another session on Tuesday, 7:30 IST time. So you have an AI Foundation course, you have a Machine Learning Foundation course. And the best part about these courses is if you're unable to join them live, you can then still view the material once the session is over. So for instance, I'll just quickly show you. So this was the first module, an AI transformational journey. And if you're going to click on view, you can go to content, and you can see slides and replay. And you also have a quiz which you can take, and you can get badges for H2O, so which you can then flaunt on your LinkedIn and social profiles. But otherwise, you get access to all the slides and all the videos here. So you can download the slides and you can also watch the videos. So that's the best way if you want to get started with it. And apart from that, if you're specifically interested in driverless AI and H2O tutorials, they're also there. We recently uploaded our MLOps tutorial too. And the best part about this is you don't have to install anything locally. You get access to our cloud environment called Aquarium, where it's a Dockerized container where all the libraries are pre-installed, and you can just simply go and work on any H2O platform from driverless AI to H2O3.
Great. And to access our academic program, you just go to the academic tab. It's fairly simple. You just need to sign up and provide your credentials. You'll receive an academic license in your inbox. And for any extensive documentation on any of our products and what we do in those products, go to the documentation site and you'll be able to find most of what you're looking for. And Parul, there's also a bunch of questions asking for the Jupyter notebook that you showed. Do you think we'll be sharing that?
Yes, I will. I will put it on my GitHub repository, and I'll share the link, and I'll put it on the slide.
We'll also send it in a thank you email. Yeah.
Yeah, so I'll put it there, and yeah, so you'll get access to the notebook.
Great. Awesome. 1 minute left. Let's try to get at least 2 questions.
Yeah, sure.
Very quickly, how does H2O3 compare with other AI platforms in terms of ease of use and capabilities?
So I think I showed you about H2O3 yourself, and I think it's more about the users. It's fairly simple. We have a robust documentation, and then like I showed you flow. I don't think any other platform has the web interface. So that really takes a lot of pain out of the whole task of remembering, which parameter is there. So I think H2O3 is a fairly easy platform to do, and which also means that we don't compromise on the accuracy and the performance.
Great, thank you. And another question asks, how far down the road are we with explainable AI?
Oh yeah.
Do you want to take that?
So I think yes, because it's heartening to know that people are taking up this question of explainable AI. And as far as H2O is concerned, we are really working towards creating a robust platform for explaining the results of machine learning models. And as far as our driverless AI platform is concerned, we have a dedicated module of machine learning interpretability, having capabilities and algorithms like Schleim, Shapley values, PDPs, variable importances, which can actually explain why a particular model, took that decision. And even in H2O3, we have partial dependence plots, variable importances. So we as a company are working and using a lot of capabilities that are available and incorporating it in our own platform so that we are able to explain why a machine predicted this for a particular question.
Great. Thank you so much, Parul, for taking the time and doing a wonderful presentation. And thank you to our attendees for taking the time and joining and asking all these wonderful questions again. We'll send out a thank you email with the recording, the Jupyter notebook, and the slides. Thank you, everybody. Have a good day. Bye.